Welcome. Now the lesson is how to make a georeferenced image by using the AutoSyn. Basically, the imagery always needs to be geometrically corrected to a map coordinate system. It is a very essential task in remote sensing analysis. This is especially true for any applications like change detection, fusion, layer stacking, mosaic, and lot of other applications. In this regard, manual point collections can be a prohibitively labor intensive work for a large area. As earlier we did in georeferencing, suppose if we take two big image, so we have to collect more points, more distributively points to match our image. But AutoSyn, it helps us to minimize our time and labor, and it is computer operated software operated algorithm within a sub-pixel classification. Within the pixels, they are extracting the similar brightness value, similar feature type, shape and size. So for this, you just go toolbox, AutoSyn workstation, click here. First you create a new project, define its folder. Here I am using already I created a folder. Okay, just you put the name. This is project file. So you want resampling, you just set bilinear interpolation. You can use other, you can use neighbor. So in this regard we are using interpolations. Just click OK. Now you give the output directory. It is better to give the same location. It is automatically take whatever the file you put. It will automatically take the that file, and it will include a suffix of underscore output. Now the next step is to put your input image. Just add input image. Here I will use a already orthorectified Carter set image. My reference image is a LIS4 5-meter resolution IRS LIS4 image of a larger area. In fact, these two images are already georeferenced, but you can check what is the difference between the two images. We just go normal Erdas view interface, open that both image and check it out whether it is matching or not. So you can do some image enhancement, so it looks better. Okay, now you put your reference image. Now you can check we can verify the influence of the two hilly river by using the sweep option. You see, this is not perfectly matched. That's why we are going for auto scene. Both the images are ortho rectified, but it is not perfectly matched. Okay, let's do. For initially, you have to set some parameters. Go to the project properties. Here we will use define the default define pattern. Column increment we can use to 28. It will search with column by column. In advanced settings, minimum point match quality you can put maximum, it is 89 is good. Then the initial accuracy 25%, it would give you good result. Geometrically you can collect, you can go for polynomial, you can check for first order. Projections, whatever you want, you can put the as same as input image, or here we will use the same as input image. All things are okay. Output it automatically, it will take the output in the same folder. That's fine. Now initially you just put some value, or you can generate the type points. So we will see, as both the images are in reference system, so you don't need to put any control point, that means the manual points. The one important thing, if you will use an unrectified or ungeoreferenced image, then initially you have to put some control point, that means the manual control points, as we did earlier in our georeference processing, normal georeferencing by image to image georectification, so georeferencing process. Now we can generate the auto type points. So here you go, the option is there, run automatic point. It will take some time. In fact, in a hilly area, due to the elevation differences, you need a proper orthorectified image. Without a orthorectified image, whatever the control points, whether you get from the DGPS survey or other good survey, it will not give you the good results. So for the hilly terrain or rugged terrain, you need a proper ortho rectified image for perfectly matching of various imagery. For any the previously I mentioned the applications, suppose the change directions, pixel based change directions, and other image analysis regarding any application. So it is going on. This is our Cartoset stereo image. So here we used on January 2010. It is 2.5 meter resolution. Here it is the list 4 image, 5 meter resolution. It is rather bigger area if you compare with this Cartoset. So one important thing I will mention here, before any auto scene, whatever the image is georeferenced, both the images are georeferenced or not, you just put some manual point. It would give you good result, because according to that manual point the type points will generate further. So due to the time constraints I did not do this. You can see it has created lot of points, more than 2000 points. Now here you see the RMS score, RMS value is 2.64. In fact it is not so good for perfectly, because these two images are very high resolution. 2.5 is compared with other Landsat or raster image. These both the images are very high resolution image. So you can check the standard deviations between your type points. So here if you here you can select the deviations. Here it is 3. You just check how much points are within this range. So you can delete this and can get your better RMSE value. So here you just open it up. Okay, that's already the value selected, so you can go here and just delete only those which is having more than 3. Now you have 1600. So it is now, you just calculate the RMSE. Now it is reduced, you see this is 1.61. Next you just go for 2. You just check how many points are within this range. So many points, so you can delete. It is rather give you the better accuracy. So here it is 1.6. So now you have 1087, but still it is not good. We should achieve less than 1. So here you can select another one within this one. So for this purpose we can delete and check the result. Now it is very good, 0.66, and now we will have 500. Is rather good. So your auto type point generation has done. Now to see the final processing, you see these are all the common areas. These are, as earlier told, it is a big area and it is a small area. And now our now you can run this. It will take some time. Now it is done. You can check here also. Some common points you can check. suppose the influence of these two hilly river. It is better to go the main interface and check what is the result. You can do some misdirection. Now you can check by using the sweep. Is quite good. The more the precise the point you will put, the more the perfect result you will get. That's fine. This is the procedure of very useful tool in AutoSim. Thanks.